Hello everyone, welcome to this video. In this video, let's solve the next question, question 20. So here they are saying if A, B, C are given to be in AP, right? These numbers are given to be in AP. B, C, D are given to be in GP. 1 upon C, 1 upon D, 1 upon E are given to be in AP. So we need to prove A, C, E are in GP. Now so much AP and GP and so many members here is confusing. So let's write it down in a systematic way. So what we are given? We are given first of all that A, B, C are in AP. So we are given this thing. So what does it mean to be in AP? We have the same common difference. So that means B minus A would be equal to C minus B. Like this. So let's mark this as equation 1. Similarly, next we are given that B, C, D are in GP. So, right, so let's write it down. Now being in GP, means we have the common ratio. So that means C divided by B would be equal to D divided by C, right? That is our equation 2. Now the next thing that is given to us is 1 upon C, 1 upon D, 1 upon E, they are in AP. If they are in AP, their common difference would be the same. They are in AP. So this whole expression minus this expression would be equal to this expression minus this expression, right? So 1 upon D minus 1 upon C would be equal to 1 upon E minus 1 upon D. This is also given to us. These three things are known to us. We need to prove that A, C, E are in GP. So what we need to prove? We need to prove C upon A is equals to E upon C, right? So let's mark this as equation 4, which we wanted to prove here. Now, how to proceed with so many information known with us? How to proceed solving this and proving this thing? So can you notice one thing here? Whatever we wanted to prove here, it does not contain B and it does not contain D. However, it contains B, it contains D, it also contains D. So it contains both B and D, right? It contains B and it contains D. So that means we have to eliminate this B and D from these equations to have this relation. That's it. That is what is required here. So what you can do, you can extract the value of B from this equation, put it here and find out the value of D from here, put it here, and you will reach at your solution. This is the flow chart of this question. So here you see, from the first equation, you can calculate what is the value of B. The value of B comes out to be equal to 2B is equals to A plus C, right? So the value of B is A plus C divided by 2. So this is our equation 5. So we are done with equation 1. Now once we have the value of B, we can substitute this value in our equation 2 in place of B. So you have C. The value of B as A plus C by 2 is equals to D upon C. Now from here, because we do not want D, so we can calculate what is this value. So we can simplify this expression to obtain the value of C. You can take it over here and then take this 2 up so that you would have 2C square divided by A plus C. Now this is the value of D. Once you have the value of D, you can substitute it here into your equation 3 in place of D here and D here. So that you would have the value of D here reciprocated and the value of D here reciprocated and the others as such. Now what you have to do, you have to simplify this expression in order to reach at your proof. So in order to simplify this, you can move this term to this side and this term to this side. There is no issue, right? So this would become positive, this would also become positive. So we have this term and this term would become 2 times. So we have twice of this particular term. So that this 2 and this 2 now gets cancelled with each other. So we are left with A plus C divided by C square is equals to 1 upon E plus 1 upon C. Now what you can do, you can separate out this term here. So it would be A upon C square plus C upon C square is equals to the right hand side as such. Now one C here gets cancelled. So you are left with A upon C square plus 1 upon C is equal to 1 upon E plus 1 upon C. Now you can either shift this term to this side and then cancel out each other. Their effect would become 0. It would cancel, nullify each other. So you are left with A upon C square is equals to 1 upon E. So what you can do, C square is basically means C into C. You can shift one C to that side. So A upon C is equals to C upon E. Or what we wanted to prove, we wanted to prove C upon A is equals to E upon C, and this is our proof, because if you have this thing, if you have this as the common ratio In that case, the numbers A, C and E, they are in GP, and this is what we wanted to prove here in this particular case. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.